Greeting to participants from USA, New Zealand, Sri Lanka, and around the world. A warmly welcome Astro Week hosted by Astronomy Inc. under the Astrobiology and Paleontology Certificate Program. Today marks as a day 6 of this exciting series for South Asian region. What we are going to talking on today, the experiments on Earth that prepare for the deep space flights. As we venture into this critical topic, we are honored to introduce a distinguished guest speaker from our special team. She's a PhD candidate from Space Resources at the Colorado Schools of Mines and also a research engineer at the Outward Technologies and also a mission specialist in a moon analog isolation experiments called a Series 19. Furthermore, she is a crew journalist for the mission Mars 116 and she is an ambassador of the Mars Society USA, also a research member at the Astronomy Inc since 2021 with her extensive expertise in space research and analog mission. She will be provide a valuable insights into the how terrestrial experiments pave the way of humans' future in deep space explorations. With that being said, I would like to invite this young, inspiring, talented, and glorious scientist Anastasia Stepanova to address Astronomy Inc. International platform. Anastasia, now it's your time. You can get started.
Hi, thank you so much for inviting. It's an honor, and I hope you will have an interesting next hour. Yes, let's get started, and hopefully one day I can visit you guys at Sri Lanka. So most of the experiments that I will be talking about, they all been done in Moscow at Institute of Biomedical Problems, this unique facility was founded in 1960s by Korolev, who is like the father of Russian cosmonautics, and IBMP in short was founded for research of the living organisms and also humans in extreme environment of space. So of course, the first revolutionary experiment on isolation in small confinement was in 1967. This experiment called Year in Starship. And three men spent 1 year in very small space station. It's not even like a space station, more like a big room, where they had to process their urine and use then the processed urine, take out of the urine the water and use it for drinking or for food. They also had different psychological and physiological experiments on them. And for their families, it's been said that they went to Antarctic station. So this experiment was in total secret. But nevertheless, the experiment, yes, there were some small, I think, conflicts because it's hard when, three people that didn't know each other before ended up in one very small space for a year. So we're all humans, and of course there will be some tension. But it just proved that the humans, are capable of surviving and doing a proper work in extreme environment. Then after that, in 90s, we had mixed gender crew, which called Sphinx 99. And here we also had some tension because there was only one woman. So the crew reacted differently to her. And that was also interesting because when we go to Mars, for example, or to the moon, we're not going to have only all men there. We're going to have, of course, females, because it's an important part of our society. And actually, it's the best, I think, the best strategy, because we are so different, men and women, but we bring different positive sides to the science and to the work approach. So I think it will be the best to have to represent both genders. Yeah, so this experiment proved that there is some issues. It can be some tension between the different genders. Later on in 2010, IBMP had still the record-breaking experiment on isolation. Just imagine this 6 men spent 520 days in isolation in the mock-up of the space station, and they simulated that they're going to the Mars and spending just a few days there simulating EVAs. You can see it on the right, and then they're flying back to Earth. So there were time delays when they were communicating with mission control, and there were different food studies. Here you can see the station for Mars 500. It's quite big, so there is a space to, just spend some time alone if you're tired of your crewmates. You can see that on top, it's a simulation of Mars surface. Underneath it, you have the storage room, then the exercise room, and then you transfer to the crew quarters. It's 6 of them, also kitchen, living room, and on the left, the small module. It's a simulation of a lander or a cargo ship. Usually, they were like putting supplies into this ship, and when you're ready, you open it and take the supplies if it's a cargo ship. And most of the time, yes, this small module was closed. And then on the far right, it's a medical module where you have all the different medical procedures and physiological studies, because it's important to see how your body changes, how your health changes. So test subjects were giving a lot of blood, urine, saliva, and a variety of other experiments. So the Mars 500 went quite well. It's a really tough one if you just consider it's 520 days, so it's more than a year spending in isolation, not seeing the sunlight, not seeing what's happening outside, talking only to 5 other people, eating sometimes not the best food because there was also food studies, and they were testing, for example, like 1 week crew had to eat everything's sweet, another week everything's salty, or like just cold. Yeah, it was not the best, but the crew did great. They survived it, and again we saw that humans are very adaptive and very capable of adapt to new environment and to survive. So that gave us hope that for flying to Mars and being on Mars actually is possible for human being. After this experiment, together with NASA, we started the Scientific International Research in Unique Terrestrial Station. In short, is a Sirius, and I was the part of a 4-month mission. The Sirius experiments, first we had 2 weeks mission. It was in 2017. Then 4 months mission where I was in 2019. After that, we had 8 months mission, and then 1 year mission. Always different crew members, but the same test research. We just wanted to see how duration affects the test subject, and in general, to see the pattern when we do the same methodics of research methodics. So the crew should be from US and Russia, or like from maybe other countries. And we had to speak both English and Russian. And in our crew, we had a real cosmonaut as a crew commander. He spent 6 months on ISS in 2014. So yeah, I can show you how did it look inside. And I know you would be surprised why we have so much wood, right? We're not gonna bring to space a space station that is full of wood. Back in the days when they were building the station, since it's fully hermetic with its own atmosphere and air pressure, inside should be materials that don't off gas, and also that are safe for the fire hazards. Well, wood is not really safe for fire hazards, but at least it's not off-gassing, so it's very ecologically clean. They decided to, have the wood on the walls, and also psychologists said that it's nice for us, for human beings, nice material from psychological point of view. But honestly, I would change it and I would make it more spacey looking, but nevertheless, we still enjoyed this our home for the 4 months. So yeah, you can see it's okay. It's not super big, but it's good enough. Here you see the mission control on the left, and on the right, it's our simulated virtual reality EVA on the moon. EVA means like extravehicular activity, or like walking on the surface of the moon. Since we don't have much space in this hangar, we decided to use also virtual reality, and actually the effect was great. If you can look on the left at top corner, that's the view of virtual reality, like the surface of the moon. And we had more than 77 different experiments on us. So we were the lab rats. So we had to measure our eyeball pressure. We had to learn how to do ultrasound of, the stomach area of like liver and kidneys, etc. It's actually pretty hard because everything seems so blurry and kind of almost the same. Then we had to give a blood, urine, saliva, sometimes even samples of our hair to test the level of stress or the level of cortisol in them. So we did, many medical experiments on us, and also a lot of psychological experiments because they wanted to see how our cognitive functions, or basically how if we came into the mission smart and sharp and focused, if this changes over time in being in isolation. And also not seeing sunlight and not getting vitamin D, which is really important for well-being, not only for your immune system, but also for your psychological well-being. The lack of vitamin D often causes the depression, so that's what they've been also looking at. This is the next series after our mission. So we had 8 months mission and new research test subjects. After that, so we finished with the part of isolation. Then we also have important research on the microgravity effects on the human body, basically the negative effects of microgravity. And for that, IBMP built a special facility, the bath filled with water. And on top of that, you have the waterproof foil, and then so the test subject wouldn't touch the water with its skin. And then you put the test subject in there, and test subject spent several days in this position and in this bath. So if, as you can see here, you're in unsupported environment and in horizontal position, and this simulates the muscle atrophy of when of the same that is happening on the ISS with the astronauts. So how this experiment really evolved. first in the early era of space exploration, Soyuz 9 had 17 days in space, and it's a small capsule, small spaceship. So they didn't move much in this spaceship. After 70 days, when they landed on Earth, they couldn't even get out from the spaceship. They had such a severe muscle atrophy and heart problems. And so this example made many scientists think that we need to create model something here on Earth in order to study how we countermeasure, how we can mitigate those negative effects of microgravity on human body. And that's how we created this special baths. You can see it here. So here we simulate three main factors on the human body, and we call it dry immersion, the experiment itself. And first, it's supportlessness. So before I showed you that you're like just floating in the water. And it's a key in the regulation of the postural muscular system. Second is limitation in your movement, in motor activity. So this also, happens on the ISS. And third is hydrostatic compression. Basically, since you're in the water and you're surrounded with water, it presses on your body, and it also changes how your blood vessels react to that. And this causes the redistribution of the blood to the upper half of the body from the lower half. And the same happens on ISS. They don't have, of course, water around them, but also the fluids or blood, the fluids are coming into the upper part of the body when astronauts are on ISS. So that's what we also simulated. And in 2020, for the first time after so many years of having this experiment, we had first female test subject. And I was, of course, in this mission because as you know, I like to be a test subject or a lab rat. So yeah, we had the all-female experiment, and we spent 3 days in this bath. Before, with all men, they spent like from 5 days to 21 days. But with us, they didn't know what to expect from women reaction to that. So decided to start with 3 days only. And you can see me here on the far right. So I'll just show you a few examples of which studies we had. So I was in this bath. I couldn't get up. They were bringing me everything, food, to clean my teeth, like water, everything, and also some systems for me to go to the restroom, right? This methodic is called food. It's how the dry immersion influences the characteristics of my food. So that's why they scanned my food. Then, of course, we had different other psychological studies and psychological support. On the far right, you can see the different colors. It's a Lucier test. Basically, you're choosing from the most pleasant color to the most that you don't like. And it apparently tells something about your psychological state at the moment. After dry immersion, we can move to the new experiment. It's a short radius centrifuge. And that's another way to fight the muscle atrophy when you're in microgravity. So the proposed methodic or like solution for the muscle atrophy when humans flying to Mars, and as you know, they would fly there for 7 months, and if they have muscle atrophy, it will be hard for them when they land on Mars to, stand up and start working. So our scientists proposed to have on board of the spaceship such a, this small centrifuge, and just I think around an hour of being in the centrifuge in rotation can simulate the gravity of pull of Earth and can train your muscles. So that's one of the future, hopefully, solutions for solving the negative effects of microgravity. And another interesting experiment, so on Mars, we have a very, very low magnetic field. And this is really important for us, for humans here on Earth, not only because magnetic field helps us to keep the atmosphere and protects from the radiation and from solar rays, but also the magnetic field interacts with our brain cells because we have this electrical signals in our brains. So there were studies on the mice, how when they decrease magnetic field and how it affects them, and basically it did affect their cognitive functions. So imagine we send astronauts to the Mars, they spend like a few years there, but like in a year they all of a sudden can become dumb. They couldn't like do things that they could do before, and this could be because of a very low magnetic field. So it just signals in their brain would work differently. And for that we created the Faraday cage and the experiment called ARFA. So here they lowered the magnetic field by 1,000 times. And they were studying this influence on cognitive function, on visual and auditory analyzer, and indicator of pain sensitivity and cardiorespiratory systems. So basically on many important, points in your body that is crucial for the mission and for your survival, how this was all affected by the magnetic field. And we had so far, we didn't see any changes, but our test subject only spent there like 8 hours, but it should be continuous if you like just live in this environment for many days. So we'll see how we can go about that, and who, which human being would apply to such a very risky experiment, because you don't want to become all of a sudden not able to think properly. So that's still in our, it's still a challenging experiment. Here you can see how test subjects spend their time, because you cannot have any mobile phone or computers inside of the Faraday cage. So they've been playing chess and talking to the our scientists to have a not boring good time. And that's all the cool experiments that I was able to watch and to work in. And I'm happy to answer your questions.
Thank you very much, Anastasia. It's a very informative and very interesting and also very short discussion. And I hope because we have a couple of segments for these sessions. And dear students, if you have the more questions, make sure to raise your hand. And right now we are moving to our discussion session. While you are just processing as an analog astronaut, how do you think how important to control the physical, mental, and other health factor? Same time that we are looking for only education factor, is it enough, or we have to just balance both sides? What is your advice?
Yes, of course. You have to balance everything, and it's a hard job. So you have to, spend a lot of time in studying, right? Being smart, but then you also need to have some time for your physical exercise and for eating healthy, for look after your health, and also for your mental health. And it's really hard because in this environment, there is a lot of stress and a lot of pressure. So yeah, I think it's quite challenging to combine everything to just be also mentally stable and find the ways that help you to get rid of the stress. Yeah.
And what is your dream while you are in the childhood, and how you just follow it?
Yeah, so of course I want to fly to space. That's my dream. And I think when I was a kid, I read science fiction books, and they were saying about this amazing future where we travel to different planets, discover them. And I know for you, as for the astrobiologist, it's one of the most exciting things. And unfortunately, we're still not close to do that. And so at least, I thought I can be part of this bigger picture of space exploration. And if science needs test subject to help for the future missions for, to get to Mars, to understand how to help astronauts survive on the Mars. So I was like, yes, use me. I want to be really useful and helpful in that. And I know it's a really small part that we test subject play in this, but still it's great to understand that you contributed maybe even a little to that.
Yeah, that sounds interesting. And what kind of subjects that you are just following at your high school and also like your universities? And as a girl, so what are the barriers that you are seeing while you are just heading with your dream?
Yeah, so my path is a bit unusual. I'm not saying I'm not recommended, but I think you can use shorter path. But I first, of course, in school we have all the subjects. Like in Russian school, you have everything. You can choose. Basically, it's like all the math, biology, chemistry, geometry, also English, Russian, history, literature. So yeah, it's everything. But then my first degree is in space journalism. And that's why I'm saying, if you want to go to space and do something, you just after school decide the best field. It's either science or engineering or being a doctor. So but space journalism, I'm still doing space stuff. So after the space journalism, I got engineering degree because that's what was required to become a cosmonaut. And now I'm getting like PhD also in science, and my PhD is focused on lunar regolith and the flow of lunar regolith in lunar environment. So I'm almost 40, so all my life I've been studying, and I have I think like 5 masters, no, four masters. Yeah, so it's a lot. It's not because I like to have collection of diplomas, but it's just because for space it's very challenging, and you always you don't stop studying and improve yourself and get new skills. And as a girl, it's even more pressure because, of course, we have bias. Girls are quite new in the space industry, and it's very male-dominated industry. So they have all the stereotypes about you. And so many times I heard, oh, what's this blondie knows? She doesn't know anything. She shouldn't be in, even close to space, something like that. And for me, it's always great to, disappoint them. Whenever I have the success, they always shocked. It was like, what? How, journalists can all of a sudden become an engineer? So, all these people create these boundaries, but it's illusion. There's no boundaries. If you want something and you work hard, you can do that. You can become whoever you want. So yeah, it's just always I think double work, because apart from just your work, you also need to prove to those men that you're capable and that you're professional. But that's the life. So no matter what, just continue working on that. That's it.
Yeah, thank you for the answering all the questions. And additionally, I noticed that you are doing some swimming, hiking, running, and a lot of activities. So, how important is that hobby and such a sport type of activities to before you enrolling with such analog astronauts or whatever positions? Can you share some of your
Yeah.
experience? Yeah.
Yes. So yeah, it's you have to be physically fit, but it's more on like all the physical activities should be focused on your endurance. So that you can withstand different activities for many minutes. So it's yes, swimming or running, but I don't like running much, but I had to do it for the cosmonauts selection. um, but swimming is one of the best. I think it's really good for your stress level, for your body in general. And also I like to do yoga. So you have to be flexible, and I think in general just being fit and strong, because when you work in space, even if you're just building space apparatus or payloads, you still need to have enough physical force and power to manage all that. But if you want to be an analog astronaut, which is very possible, we have so many different space stations and missions all over the world. It's also physically challenging, because they have to wear the spacesuits and they're heavy, and then you have to work for several hours outside. So yeah, you just need to prepare to be just physically fit, endurance, and yeah, trying to working out whatever exercise you like, but choose what you like. It can be yoga, boxing, swimming, running, or just going to the gym and doing different things, but always stay healthy. Yeah.
Yeah, that sounds interesting. Dear students, if you have other more questions, please raise your hand. Today, what we have been just discussed, before we move into the moon or Mars, so we have many things to do, specifically analog astronomy and a lot of activities we need to do. We know, we both are ambassadors of the Mars Society, and I noticed that you have been supporting them for their Mars rover challenge missions in Utah Desert as well as the MDRS. So, what is your experience with the MDRS, and how important such a ex-situ analog stations to understand in Earth Mars analog is?
Yeah, the analog stations and missions are really a great way to test, many different experiments, and to see the different factors and challenges that we're gonna face in space, because it's so expensive to bring anything to space, right? So we cannot bring all the equipment we have here, all the different scientific methodics. It's just impossible to do all that. That's why we create this kind of simulation or analog stations, and I think we can get a lot of useful data out of it. And I think also astronauts who would prepare to fly to Mars should spend, before flying to Mars, a time in analog mission together, isolated, and I think it will be good training for them. And about Mars Society stations, they're great because of the astrobiology and geology purpose, because other space stations, they're mostly concentrated on humans, right? Human factors, etc. But with Mars Societies, they also have the field studies, how we can explore the Mars, what will be, which research will be useful, which is not. So that's really great, I think, for the biologists and geologists to go there.
Yeah, indeed. As you mentioned, it's a highly important, even though to furthermore testify some of Mars regolith that we developing here. Even we just share with the MDRs and their experience, expertise, knowledge, and everything are really supportive to the many of young aspiring people who are around the world. Yes, I noticed another students have been raising the hand. I'm not sure what exactly name. Before you ask in the question, make sure to mention your name. I think Dan Siri. I know that it's you are pretending with some of your father name, maybe. Yes, you can just open your microphone and first. Yes, open your microphone. Yeah, it's leaving, I think. Dear student, is there any questions to ask him? Because of next week, we are moving to the little bit hard theoretical sessions. Before that, we need something like very free and very enjoyable, inspiring session, just like Anastasia done on today. And I noticed that Danita, Devina, Monica already asked, Joanna, Liana, and Itupa, Tiveng also asked a question, and Rukshani and Sentu. If you have further questions, please raise your hand. Otherwise, you can just drop the questions into our WhatsApp group. Then after that, I can just share with the Anastasia if it is something like questions. In the future, we can just have in some opportunities and other purposes. And also, Anastasia, I think like this is a very short sessions on today that we are just planning, and I would like to passing our special gratitude and the greetings to you on behalf of the Astronomy Inc, because of each every time you are truly inspiring our students and all the people in South Asian region, because of we know that it's a very lack of knowledge and the facility around in this region, and but we have a huge network using the even astronomy. You are supporting us, I think, like last 5 years, and it is truly amazing, like gathering the people, discussing something new, and looking for some best hub life stations out of the planet Earth. That's the best thing ever be looking for in the future. And at the end, what is the advice that you are looking for giving to the young people to become their dreams?
Yes, I know life is hard, and not always you have everything, to succeed. Always, like, some people don't have money to pay for their education, for this and that. But I think don't let this obstacle stop you. If you love something with all your heart, like it can be science or engineering or space, just continue working hard towards this, and life, universe will send you help. Like you can win different contests and not spending any money, but someone else will help you out with this. So I think just follow your heart and work hard.
Thanks for your advice and everything, Sadia and Anastasia. And at the end, I wish you very all the best for your future career. I hope like soon we can just meet and just working on some more projects. There are a lot of projects are ongoing currently, and we have a lot of friends. I feel like that will be really affecting to the many of Indian and Sri Lankan students to find their exact. Thank you very much again, and for joining us, dear students. For today, I'm going to end up the sessions.